Good morning, everyone, and welcome to part 3 of the FoRRRwD webinar series. My name is Mike Fitch with the Ohio LTAP Center here at ODOT, and we appreciate your participation. As we get started, please take a moment to locate the questions box in the GoToWebinar panel. During the presentation today, please use the questions box to send in any questions you might have. With that, we will go ahead and turn things over to Ray Brushart. Hello.
Hello, Mike. Thank you for that introduction. Good morning, everybody. This is Ray Brushart once again. You've made it to session 3 of 4 of our FoRRRwD webinar series. And of course, FoRRRwD stands for Focus on Reducing Roadway Departures. And we're going to continue talking about countermeasures today that focus on the number one strategy of the 3 strategies, and that is to try our best to keep cars on the road. And so we're going to talk about our rumble strips and rumble stripes this morning. We'll probably get all the way through these, and then we'll go on to the next subject, which will be, providing a recoverable area. Okay, so rumble strips and rumble stripes. Let's get cracking on this. Okay, so our learning outcomes on this subject will be that after all of this, you'll be able to describe a rumble strip and a rumble stripe, and you'll be able to describe the placement criteria and installation considerations for rumble strips and stripes. And you'll also be able to recognize the crash reduction potential for rumble strips and stripes. So let's do a knowledge pre-test, and we're going to watch a video, and we'll ask you what is the concern raised in the video, and then what countermeasure could be used to address this concern. So let's watch this video.
I sit and replay that night over and over and over again, and I thought, I'm just so close to home. How'd you make it?
That night, Rusty Burris was 18 years old with a bright future. But driving home from his girlfriend's house, his life changed forever.
I knew I was tired, but I didn't really feel that I was that tired. And driving home, I got just a mile from home and fell asleep at the wheel.
In seconds, Rusty's car drifted off this country road and rolled over. The impact crushed his roof and his spine. Rusty would never walk again.
I've fallen asleep and crashed my car one time. And that's all it took.
Experts say every day, millions of teens are dangerously tired when they get behind the wheel. More than a third of teens say they drive drowsy on a regular basis, and more than half of all fatigue-related crashes involve drivers under 25.
Okay, so we have some fatigued drivers, young drivers, and they talked about one driver who unfortunately was in a crash where he fell asleep and went off the road, and so he was seriously injured. So can you think of a countermeasure that we could use that could possibly have prevented that type of crash and other fatigue related crashes? So, well, I think we know where we're going with this, and the answer is rumble strips or rumble stripes. So that's the job of these rumble strip is to keep drivers alert, let them know when they've drifted to the outermost boundary of their lane, or be just off the outside of their lane if it's on the shoulder. And we'll also talk about how it helps with other types of crashes. One of those is distracted driving, of course, which is a very serious concern these days, as everybody's driving around looking at their phones. So, you know, that can prevent the distracted driving crash as well. Okay, let me get past that. Okay, so typical crashes and causal factors addressed by the use of rumbles. Our primary focus is on distracted driving, drowsy, or inattentive driver. And you know, a little reminder that we have in the handout section of on your screen is a PDF of this PowerPoint, and so one of the reasons we want you to download it is because we have all of these handy dandy resources that have a lot more information on the subject matter we're talking about. So there's a link right here on the screen for NCHRP Report 500, Volume 14. You know, there's several volumes to Report 500, and this one deals with a guide for reducing crashes involving drowsy and distracted drivers. So there's you can read up on that. And in the crash types that are addressed with the rumble strips and stripes is, of course, what we're really focusing on is roadway departure crashes, which include run off the road crashes and head-on crashes. So they're either leaving the road to the right or crossing the center line. And of course, these rumble strips can be placed on both the edge line or just outside the edge line, and also on the center line. So there are different methods of producing or installing the rumble strips. And so we have the rolled rumbles. They're rolled into the fresh layer of asphalt. And then you have the milled rumbles, which are grinded in afterwards. And then the raised rumbles. And either, as you can see, different types of products for the raised rumbles from the marking materials, or even ceramic type buttons and stuff like that. The rolled rumbles are not to be used much anymore, as they have to be done at the time of paving, and they do not produce as much noise or vibration as milled rumbles. So the milled is the preferred. And the raised rumbles may be used on the PCC pavements or where the pavement structure does not allow for milling. And thermoplastic markings can be applied to create a profile marking, which also produces a rumble effect and enhances visibility of the marking. A few agencies have used this treatment with good results, but there has been no evaluation comparing raised rumbles to the milled. In addition, in snow zones like Ohio, raised markings will require more maintenance. All right, so you can find out more information on this on NCHRP Report 641 on page 117. It's called a study of effectiveness of various rumble strips on highway safety, which is done by the Virginia DOT. Here's some more resources on rumble strip guidance. So there's these technical advisories, and the first one there talks about the shoulder rumble strip, which is a longitudinal safety feature installed on a paved roadway shoulder near the outside edge of the traveled lane, and it's made of a series of milled or raised elements intended to alert inattentive drivers through vibration and sound that their vehicles have left a traveled lane. Then you have the edge line rumble strip, which is a special type of shoulder rumble strip placed directly at the edge of the travel lane, usually with the edge line pavement marking placed through the rumble. Then you have the center line rumble strip, which is a longitudinal safety feature installed at or near the center line of a paved roadway. And it's made of a series of milled or raised elements intended to alert inattentive drivers through vibration and sound that their vehicles have left the travel lane. In most cases, the centerline pavement marking is placed over the rumble strip, which is sometimes referred to as a centerline rumble stripe. And the edge line and centerline rumble stripes are made when a marking is placed over or on top of the rumble, where the marking material on the sloped face of the rumble can still be visible under adverse, like wet or rainy conditions. So you can find these on the FHWA safety website. And there's the link is right there in the box. And then over here on the right, we have the resource from the FHWA safety program titled Decision Support Guide for the Installation of Shoulder and Centerline Rumble Strips on Non-Freeways. All right, so let's talk about our milled rumble strip dimensions. And you can see we've got milled rumbles on the shoulder and center line. And these drawings that you see there are based on the NCHRP report 641, but they're modified for the FHWA Technical Advisory 5040.39. The Missouri DOT has been using these, and they reported that the milled shoulder rumble strips can result in 12.5 times higher vibration stimuli and 3.35 times higher auditory stimuli than the rolled rumble strips. And the Virginia DOT did a study of effectiveness of various rumble strips on highway safety as well. And they tested for sound level tests under 65 miles per hour. The milled rumble strip sound excess level is 335%, or 3.35 times more noise and 12.6 times more vibration than the rolled rumble strips. So there's some more reasons why we're preferring the milled rumble strips. So these are the typical dimensions that you see. And then on the top left picture, you can see that there's a gap at certain intervals there, and it's actually to help bicycles. And we'll talk more about how bicycles can benefit from the rumbles as well. And here's the milled rumble strip dimensions. So the typical rumbles that are milled are 12 inches to 16 inches in length on the shoulders and 8 to 12 inches on the edge lines. And some installations of narrower rumbles have been tried, but these will produce less noise and vibration. And, you know, sometimes that's okay because as we'll learn, you know, sometimes the public doesn't really want rumbles on the road because of the noise. And so we'll get more into that as we go along here. And so as we see here on the lower right, where the pavement surface is continually ground down, they're called mumbles if they have less vibration, and it's called a sinusoidal pattern. And so we'll discuss. We'll also discuss mumbles here in a little bit. So they produce a little less noise and vibration. Okay, so up in Michigan, they've done some studies on edgeline rumble stripes, as you can see in these pictures. And so agencies in Michigan began to explore the retroreflectivity and longevity benefit of markings applied directly on the rumble, creating a rumble stripe. And several states prefer to install the edge stripe on the rumble, as this can enhance the visibility of the strip with a more vertical surface, it may reduce wear as most drivers will stay off of them. And the Michigan initiative, which is shown, installed a new strip on the existing rumble, resulting in 2 stripes. And as a note, this does not meet the MUTCD, but was done for comparison purposes only. Some states are doing similar, but with removal of the old edge line stripe, which results in a wider lane, a narrower effective shoulder. And the photo on the, hang on here, what I do here. Whoops. What I do, go all the way to the end? Hang on a second here. Let's get back to my slide. I was going forward the whole time. Okay, come on, Michigan. Figures Michigan would do that to me, right? Okay, so where was I? Here we go. So as you can see, in the wet weather and in rain, you can still see, you know, the reflectivity of the edge line, and so that helps motorists out with safety benefit as well. And so that is, you know, one of the benefits of the rumble stripe. And so it's actually becoming quite popular since you know, this study resulted. So I mean, you'll see a lot more. You've probably seen a lot more of this even in Ohio in the last 3 or 4 or 5 years. Okay, so NCHRP did some studies, some research studies, and on the edge line and shoulder rumble strip safety effectiveness. And the first one is the NCHRP report 641 for rural freeways. And in that research, they determined that there was a 10% reduction in the SV, see, that's the run off the road crashes, a 17% reduction in the run off the road fatal and injury crashes. And that's from the Crash Modification Factor Clearinghouse, ID 3447. And then on the rural 2-lane roads, an even higher reduction in these run off the road crashes, single vehicle run off the road crashes, and the even a lot higher reduction, 36%, in the single vehicle run off the road fatal and injury crashes. So, and even better, and that's just, and if you really think about it, it's like, how many crashes do we think that we, you know, that we actually prevented? Because obviously, if a crash doesn't happen, it's not reported, right? So that's something to think about as well on that. But there's you know, some more resources for you to that you can check out, and they're free. So that report 641 is the guidance for the design and application of shoulder and centerline rumble strips. So how about we ask a question, Mike, about anybody in the in class today? Do you does your agency use centerline or edge line rumble strips or stripes on your 2-lane rural roadways or any of your roadways? You can answer in the chat box.
Okay, we have the questions box open. Response from Brian, you bet we do. So that's yes. We'll see if anybody else types in. Yes from Michael. Yes from Mike. Okay, Sarah says not many in our county. Brent says no.
So where's what county are you in, Sarah? Are you in Ohio or are you out of state?
Sarah says she's in Lucas County.
All right.
Stephen says, yes, we have used them on highway safety projects.
All right.
So yeah, we have several yeses.
Okay. Yeah. Back up here. All right. Well, that's good that they're becoming a lot more common than they were 10 years ago, of course. But I like it that I see it quite a bit on our 2-lane rural roads, not just ODOT routes, but I've also seen them on county roads in Ohio. So that's where we really want to see these become even more common and to be used in resurfacing projects usually, or because you want to make sure that it's got a good surface on the roadway, and there's probably going to have to be some public interaction, and then have some meetings, and then as we'll talk about that in a little bit, how we can appease the public and have good explanations to them, and talk about things like reducing the noise, external noise. Okay, so let's talk about the placement of our centerline rumble strips and stripes. On the left, you see the pavement markings, a double yellow, and the centerline rumble strips are milled across the joint, and then you stripe over the rumble. Let me find this. So, I mean, there's different designs for the centerline rumble. The typical installation would be across the joint. And, sometimes you get concerns for the joint on a 2-lane roadway, or a desire for more separation. And the rumbles can be installed on each side of the center line. And of course, you're going to have a certain width of pavement to begin with. Probably a 20-foot pavement to begin with. Some states use a variation with leaving out every third rumble, and this may produce a different sound and may be less aggressive. However, since it's usually under the driver, it isn't expected that this will have much effect on the performance of the rumble in reducing the noise and vibration. So, these have been around long enough for enough public meetings and things like that, and experience with the rumbles. We know a lot more than we did 10 years ago. And so there's different methodologies or designs in different locations, so that we try to make everybody happy. Some are very rural locations, but then again, you get some closer to a lot of residential areas. And so that's therein lies the reason to do our best to install a countermeasure like this that isn't going to tick everybody off in the process. So then we have in the center picture there, you see centerline rumble stripes with variable spacing. Sometimes that helps. And then you have the centerline rumble strips on each side of the yellow centerline markings, as you can see there. So that's the least common. That maybe there was more concerns in that locations for about maybe degrading the joint area or something that might damage the roadway. Okay, so there's been some studies on the centerline rumble strips, safety effectiveness, especially on the rural 2-lane roads. Again, it's NCHRP report 641. And so they've studied it, and they've come up with these crash reductions. So a 4% reduction in total crashes. That doesn't sound like much of a benefit, does it? And then they have a 9% reduction in fatal and injury crashes, 37% reduction in total target crashes, 45% reduction in fatal and injury target crashes. So that's from the Crash Modifications Clearinghouse. So the target crashes that they're talking about are the head-on and opposite direction side swipe crashes. So that's the target crash when you put these rumbles on the center line. You know, we're trying to prevent people from crossing the center line, obviously. And so again, we've given you a link so that you can go directly to the NCHRP report 641 titled Guidance for the Design and Application of Shoulder and Centerline Rumble Strips. And on the far right, you have these cards here that FHWA printed up. And you can actually order these cards off of the FHWA safety website. And so each one of these countermeasures has its own card front and back, and where they have pictures of it on one side, and then the other side has more information and links and things like that, and also some expected crash reduction numbers as well. And then we have some other rumble strip and stripe considerations as well. You know, pavement concerns. You know, we talked about the joint, how there's sometimes concerns about how installing the centerline rumbles can affect the joint in the middle of the road where the two lanes come together. And then noise and vibration, you know, for the residents, and then bicyclists. You know, we can't stress how important enough how bicyclists are to us here at ODOT. So, you know, we're putting bike lanes in all kinds of places, and even bike paths and everything. You know, we concern ourselves with the safety of bicyclists and that they're a part of our roadway. And so bicyclists, of course, you know, they do have concerns about these the shoulder rumbles and the edge line rumbles, about how it affects their ability to ride on the roadway and their safety. So let's talk about each of these. So the rumbles on the joint. So this is the center line on a 2-lane road. So there are concerns for these rumbles. And you know, we've developed some techniques to improve the joints. We've learned, I mean, this isn't something brand new. We've been doing this for a while, but on a 2-lane road, we use a wedge joint, as you can see a picture of there in the bottom right. Instead of doing like a side-by-side with the paver, we're actually able to create this wedge joint, or a notched wedge joint between the two pavement mats. And so that's where the paver is going to make the first pass straight and then properly compact the joint and then mill out along the existing joints. So I know, I think Brian Schleppy's in class, right? He's probably aware of this type of installation. But if you're planning on installing these centerline rumble joints, then this is how you should resurface the roadway. So that's something you should talk to with your contractor about, and put that in your plan. In Ohio, we've got lots and lots of lane miles of chip and seal roadways, and so you might be asking yourself, can you do this on chip and seal roadways? And so the states of Michigan and Washington have done some studies. They have some experience installing rumbles on chip and seal roadways. So Michigan has they've milled in the rumbles on chip sealed roadways, and Washington has chip sealed over the rumbles. And so with their experience, it says that they may want deeper rumbles to accommodate future chip and seals. But they've determined that as long as the rumbles are still visible and make noise, they still have some benefit to keep drivers alert. But at this point, we don't know of any real research studies on these, but they are being used on these chip and seal roadways. So maybe even ODOT has some chip and seal. We've began to chip and seal some of our lower volume state routes. So who knows, maybe we'll decide to try this out on those roads. So again, here's another resource for you on rumble strip noise factors. They're still in part of that NCHRP report 641. And in this report, they talk about internal and external noise from the rumbles and how they're affected by different variables. So we have the depth of the rumble, the width of the rumble, length of the rumble, spacing of the rumbles, and the speed of the vehicle as they drive over them. So each one of these factors affect the noise heard outside the vehicle, along with the noise heard and vibrations felt inside a vehicle. Okay, so on the issue of addressing rumble strip noise issues, again, if you look at page 140 in this report 641, and also FHWA booklet on that, well, I showed you earlier, the 5040.39, there's information on that about complaints from residents that live near installations of rumbles. And of course, that's not uncommon. In most cases, it isn't that the rumbles are resulting in a higher noise level, but that they are a different pitch, it says. And it says for shoulder rumble strips in this report 641, it says consideration should be given to terminating the rumble strips about 650 feet prior to residential and urban areas. This threshold value is based on studies that showed noise impacts from this distance proved tolerable to nearby residents. And then let's see, even the Oregon Department of Transportation has produced a technical guidance on that says that they have produced some further rumble strip use guidance documents. So you can go to oregon.gov/ODOT/engineering document/technical guidance. And they have produced, like I said, some guidance documents based on their experience as well. So in the experience, of course, like right on the slide, says discontinue or interrupt rumbles near intersections, driveways, and turn lanes, and structures like bridges, catch basins, drainage grates, Areas with limited lateral clearance or where off-tracking could occur. And besides the prior to residential areas to mitigate complaints. And we can adjust the dimensions of the rumbles, depth and spacing when the noise issue is involved. And there's a drawing there from the Oregon Department of Transportation showing a gap pattern and how they deal with a typical T intersection on an undivided highway. Okay, so when we alter the dimensions of the standard milled rumble to lessen the noise, we're creating a mumble strip. The mumble strips were first evaluated in California and Minnesota as they were evaluating various widths and spacing. And the preliminary results showed a reduction in external noise. And the safety benefits have not yet been determined. But these are very promising when we otherwise would not be able to install rumble strips. But right now we have little to no idea of the effects on bicycle accommodation or pavements at this point. The experiments in Minnesota and California have shown a substantial reduction in external noise and some reduction to internal noise and vibration, but there may still be enough vibration and or noise internal to the vehicle to alert drivers. But again, it's yet unclear, so they're probably going to be studying these things further. For some sites, there is significant difference in internal noise between pickup trucks when compared to your typical sedans. Caltrans compared theirs to their 5/16" rumbles, and Minnesota DOT compared theirs to their standard 1/2" to 5/8" rumbles when they're evaluating these. So there's some pictures on the right of these mumbles of what they look like. Okay, let's talk about bicycles, what they think of the rumble strips. Okay, in the FHWA Technical Advisory 5040.39, they looked at installing the rumbles 4 feet beyond the edge of pavement, which was preferred for bicycles. You can see in the picture there, it kind of puts the bicyclists in danger because they're in the lane of travel there with that particular type of bicycle. And then you have a picture of on the bottom there, a very wide shoulder for bicyclists to ride on. But when it comes to bicyclists, it says wear shoulders, and it's in this in the FHWA safety website on rumble strips. It says where shoulders are available and clear, bicyclists will often choose to use them to avoid conflicts with faster moving vehicles in the travel lane. However, as legal road users, they may also be in the travel lane. There are a number of measures that should be considered to accommodate bicyclists. And it goes on to say, though some bicyclists have noted that they like rumbles as it gives them warning if a vehicle is coming up from behind them. So that's important information to know if you're a bicyclist, that someone is coming up from you from behind. As the picture there on the top left, obviously the cars are not going to be driving over those rumbles unless they're really drifting out of their lane. Since installing shoulder or edgeline rumbles can affect the bicyclists, let me see here. So let me read it. This is kind of odd. It says installing shoulder or edgeline rumbles can affect the available width beyond the edge line for bicyclists, there are some options a road agency can explore to better accommodate bicyclists. So we want to ensure that there's a wide enough paved shoulder for bicycle travel. A 4-foot shoulder is preferred for the bicyclist and recommended as part of new construction and reconstruction projects. Some agencies may have different minimums, and the width may need to be increased if riding next to curbs, guardrail, or other longitudinal objects. And using an edge line rumble or smaller offset could also make more of the shoulder available for bicyclists. And we can incorporate gaps in the rumble so that a bicyclist can move between the lane shoulder without traversing the rumble. And inside the technical advisory, it shows a range of gaps and rumble lengths. And so it says the Oregon Department of Transportation example shown earlier uses 12-foot gaps every 48 feet. And so some agencies use shallower rumble dimensions, like they'll use 3/8 of an inch in depth versus the typical 5/8 of an inch as an acceptable compromise. So, this slide is probably getting to be about 5 years old. So they've done some even further research and experience with bicyclists on these as well. So that they must have had some good experience, and because these rumble strips along the edge line and on the shoulder are becoming very common these days. Has anybody in class had any experience dealing with their agency and interaction with bicyclists when they're preparing to install the any rumbles? You can answer that in the chat or question box. Just wondering. Okay, let's talk about the operational effects of rumble strips on 2-lane undivided roads. When we talk about the centerline rumble strips, it's shown that there's no adverse impacts on lanes that are greater than or equal to 10 feet. So if you have a 20-foot wide pavement, you can definitely install the centerline rumble strips. And they've been found to help center the vehicle in the lane when shoulders are 1 foot to 2 foot wide. And then when for centerline and edge line rumble strips studied together, it showed that there's no adverse impacts on lanes greater than or equal to 11 foot. And it helps to center vehicle in the lane when shoulders are 3 foot wide. So that's more in line with an ODOT 2-lane state route. You rarely see, there's a lot of township and county roads, obviously, that don't meet those dimensions. Another resource we have on rumble strips and stripes is the FHWA rumble strips and stripes website, which you have the link there at the top of the slide. So on that, they have some good information on mitigating noise, pavement, and maintenance of the rumble stripes, policies, guidance and research, frequently asked questions, how to accommodate all users, information on design and construction, and a lot of safety statistics from studies and other general information. So I highly recommend checking out the FHWA website on rumble strips. Another resource we have I was going to show you is on our LTAP website. If you go to the LTAP homepage and click on technical assistance, Then you can find our RON update section to click on, which stands for Route of Navigation. These are tech briefs that we create, especially for local agencies to read, and we have a whole section on roadway safety RONs. And so we've included this one here, keeping vehicles on the road with rumble strips and stripes. And this was created, a lot of information from the FHWA website and a lot of stuff that we've gone over so far today. But this is something that you can download and print out and whatever you want it to do. You view it on, it's got all the links in here from different resources to click on. So every countermeasure that we've talked about, we've created for this webinar series, we've created a RON update for. There's a couple of them in the handout section on clear zones right now. Just wanted to share that, you know, the ODOT, the LTAP website, Ohio LTAP website is a good resource of information for roadway safety. Okay, so let's see if we've accomplished our learning outcomes for this section. So can you now describe a rumble strip or stripe? And what are the characteristics of a milled rumble strip? Let's go ahead and have people answer this, Mike, in the question box.
All right, the questions box is open.
Yeah, yesterday and last week I could see the question box, but I don't have it on there today. So you'll have to let me know what they're saying.
Okay. And so Brian typed in noise and vibration maker with vehicle interaction typically at center line or near shoulders or paint lines. Thanks, Brian. So Kevin says strip is wider, stripe is narrower, overlaid with markings. Thanks, Kevin. So Ray, there you go.
All right. All right, let's see if our next question, we can get some more interaction here. Let's see.
Ray, Dave has
Okay.
typed in series of dips ground into the pavement to generate, he said, to generate an irritating noise.
Yes, whatever it takes to wake people up and get them to focus, right? So here we have the characteristics of a milled rumble strip, which again is a preferred rumble strip, a 1/2 inch to 5/8 inch deep, 7 inches longitudinal on the shoulder. It could be 12 to 16 inches laterally, and on the edge line, 8 to 12 inches laterally. And, you know, and that's not like I've shown in this presentation. You know, different agencies have different specs. So, I mean, you can always go online at our roadway engineering page. I'm sure at ODOT has some specs for our different rumble strips. So you can check out what ODOT is actually using on different roadways, and the edge line rumble versus shoulder rumble versus centerline rumble. And of course we have rumbles on the freeway outside of the edge line, usually 2 feet outside the edge line. So you know, the ODOT roadway engineering page has a lot of information on technical information like that. And you can make a rumble stripe by installing pavement markings over a rumble. for improved visibility on dark, rainy nights. Very good benefit. Don't you hate it when you're driving down a dark roadway and you don't know where the edge line is when it's raining?
And Ray, we have additional comments people have typed in. Can be raised, milled, or rolled. That's from Mike. And Tanvir says, road pavement safety feature that alerts inattentive drivers by causing vibration.
All right, very good. Okay, let's go on to another question. Describe the placement criteria and installation considerations for rumble strips and stripes. So what should be considered when installing rumbles? What do we talk about on that?
And the questions box is open. Michael says lane width. Barbara says residential areas, driveways, cross streets. Kevin says lane width, shoulder width, vehicle speed. Sarah says residential area if there are bike users. And several additional comments regarding bicyclists or bicycle traffic.
All right, very good. So we went over a whole list of considerations from bicycles and different noise levels and how to design them, the rumbles to produce different levels of noise and vibration. We showed how different DOTs like Oregon, how they had a technical drawing showing how they design their rumbles near intersections, different types of rumbles for different considerations, width of lane, proximity to edge line. Okay, so we need to one of the learning outcomes was to recognize the crash reduction potential for rumble strips and stripes. So what are the crash reduction factors for edge line and centerline rumble strips on 2-lane rural roads? Anybody remember that?
All right, and the questions box is open. Kevin says, don't remember, but much higher for head-ons and swipes.
Yes, that's definitely true.
David says 45% reduction in targeted crashes. Michael says 45% reduction for fatals.
All right, good job, guys. Well, if we go back to these trading cards that FHWA prints out, we can see what they say about the crash reductions by looking at the back of them. So there's a card for edge line and shoulder rumbles and another card for centerline rumbles. And they show that for the edge and shoulder rumbles on these 2-lane rural roads, there was a 36% reduction in fatal and injury crashes. And for the centerline rumbles, for the targeted crashes of this opposite way side swipe and head on, there was a 45% reduction in fatal and injury crashes. And in my opinion, these numbers are low because, like I said, we don't have any data on all the crashes that we prevented, right? No one fills out a crash report for a crash that didn't happen, right? So, definitely some, what they're doing there is strictly looking at 1 year's, maybe 1 to 2 to 3 years of data after the installation, comparing it to, the years before the installation. Okay, here's another question for our post-test. What are some of the issues we discussed that are shown in these photos?
Okay, and the questions box is open.
These pictures kind of have that look like they're somewhere out west, don't they?
Brian says, paint looks iffy on Centerline.
Mm-hmm. These pictures were actually taken in North Dakota. They might look like somewhere rural in Lucas County, but you know, that the flat land up there, but actually from North Dakota.
Curtis says, deterioration of pavement markings.
Mm-hmm. All right, see if we get somebody else real quick here.
Brian says, do they have traffic in North Dakota?
Not when these pictures were taken, right? I'd kind of be scared to be a bicyclist out west in the middle of nowhere with no other traffic around. You need that other traffic to scare off all the grizzly bears, right?
David says, rumble strips in snow areas. Mubin says, RPM missing in Centerline.
All right, let's see what we were shooting for here. Whoops. I went too far. I forgot that we can't go backwards on this. All right, so what we're shooting for here is rumble stripes improve visibility, even in rainy conditions or whatever. The narrower edgeline rumbles reduce the impact to bicyclists, so there are bike gaps. Apparently there was bike gaps. They're hard to see in this picture. I think this is a trick question. Centerline and edgeline rumbles together where there are 11-foot lanes. A different pattern of rumbles. And rumbles may help if the road is covered in ice, apparently in the second photo. Rumbles may help if the road is covered in ice. All right then. Apparently this is some of the information you would discover if you went into that technical advisory where they're, you know, they have some reports from different states and their experience with different designs and patterns of rumble strips. So I guess we can't stress that enough, that there are different designs and patterns out there that you should look at for each of your different locations. Have, you know, each location may have different, you know, concerns. So we don't want you to immediately dismiss the use of rumbles. You know, take into consideration these different designs and how other locations that may be similar have addressed the issues, and they went ahead and installed the different designs, and they, you know, still got the effect, the safety effect of reducing crashes. So I think that is the conclusion, or the bottom line here for rumbles. You know, there's not just one set design. Okay, so any other questions or input from the group on anything you want to say about rumbles?
I think we're good for now, Ray.
Okay. All right, well, we're going to move on to our next countermeasure. How's that? Let's see, let's find it here. Okay, so now we're going to move on to our second strategy in reducing fatal or injury crashes, roadway departure crashes, and that is to reduce the potential for crashes after a vehicle has left their lane. So this picture is from Tallahassee, Florida area. You can see, what do you see in this picture? If someone goes out of their lane, goes off to the right side of the road, they have a recoverable area there. So it's not a deep ditch, and there's no trees along the edge of the pavement, no bridge abutments there that are unprotected. So, you know, the idea here is the car can go off to the right and recover and get back into their lane without a crash ever happening. So our learning outcomes for this session is going to be identify countermeasures that can reduce the potential for a crash if a vehicle leaves the roadway. We'll also define what the clear zone is. So here's our knowledge pretest. So let's take a look at that roadway on the right. It's very different from the Tallahassee, Florida picture, isn't it? So what road elements do you see that might contribute to a crash if the driver leaves the roadway in that picture?
Michael says, wow.
Okay, well, besides wow, what specifically do you see that might contribute to a crash?
Bobby adds, holy moly. Sarah says, narrow shoulders, deep ditches, no guardrail. Barbara says, adjacent slope. Michael says, small shoulder, steep slope, no guardrail. Tanvir says, crazy deep ditch without any guardrail. Brian adds, steep banks, high risk potential. Michael adds, and a rough road.
Yes, those are all correct. So we've got, you know, oh, let me go back here. What do we do here? Let me go back. So definitely see basically no shoulders, a steep slope, and the slope could be so steep that it causes a rollover, which is bad news for that particular car because what's at the bottom of the ditch? We've got some water. So you could end up upside down in your car in water. Not a good outcome. So yes, we can see what's wrong with this roadway. The potential for a back crash is definitely there. So again, to summarize what our roadway departure objectives here are, first we want to keep the vehicles on the road with the different countermeasures. Secondly, we want to reduce the potential for crashes. And thirdly, if there is a crash, we want to minimize the severity of that crash. So we're here to talk about reducing the potential for crashes if a vehicle does leave their lane. So the particular countermeasures that we're going to be looking at here are the shoulders on the roadway, the safety edge, a centerline buffer, the clear zone, and traversable slopes. So these are our countermeasures we want to go over in this session. So again, FHWA has produced these playing cards with each one of these countermeasures. And so let's talk about shoulder widening here. What can shoulder widening do for us? So the motorists rely on shoulders to recover, especially critical on horizontal curves. So we've learned that curves are very common places for vehicles to leave their roadway. Not just crossing the center line for a head-on crash, but also leaving the road to the right. So it's especially critical to have shoulders in the curves. The presence of shoulders, paved or unpaved, can have a major impact on the ability of a driver to regain control if they leave the traveled way. While it may not always be practical to widen the highway to provide shoulders, consideration of widening in critical locations such as curves where roadway departures are more probable might be appropriate. So let's take a look at the safety effects of shoulder widening. So this figure shows the relationship of crash reduction and shoulder width. The crash reductions were adapted from the Highway Safety Manual for two-lane rural roads with no existing shoulder. So, we compare everything to a roadway with no shoulder starting out, and then the Highway Safety Manual figure was adapted to show the reduction factors, as it is sometimes easier to understand the reduction rather than the modification factor. So the Highway Safety Manual crash modification factor uses a 6-foot wide shoulder as the baseline. And so if we take a look at our picture here, our graph on the right, you've got the comparison of the average annual daily traffic vehicles per day versus crash reduction. And so if you start off with no shoulder and you add a 2-foot shoulder to the roadway, as you can see, depending on the average annual daily traffic, if you go up to even 2,000 vehicles a day, which is a common AADT for rural roads, you can have a 13% reduction in on that roadway. And then as you continue to, for the 2,000 vehicles a day, adding in another 2 foot to make it 4 foot, you've got 23%, and then a 6 foot is 33%, 8 foot is 42%. So some of these are obviously laughable. We're not going to put an 8-foot shoulder in most cases on our Ohio 2-lane rural roads, because that'd be a whole lot of real estate to purchase, wouldn't it? But as you can see, the point here is that maybe in some cases you can have room to add a 2-foot shoulder in critical areas like your curves or some other location where it would be suitable. So there's a before and after picture there on the left. So as you can see, they actually put in at least a 2-foot paved shoulder there on this particular roadway. So Alabama has done some projects they created a shoulder widening program. And so, you see a before and after picture here. They actually put a 2-foot shoulder and even put rumbles on the shoulder. So they've added a 2 to 4 foot shoulder on 2-lane or 4-lane rural roads. The picture shows a 2-foot shoulder. And this study spanned over 5 years of projects representing about 700 road miles of adding shoulders only, or shoulders with rumbles, or shoulders with rumble stripes. Additionally, the benefit cost ratio for 2-lane rural roads of adding a shoulder only was 53-1. This would likely be much higher if widening only in the curves. So there's actually they produced a technical advisory on this called A Study of the Effects of Pavement Widening, Rumble Strips and Rumble Stripes on Rural Highways in Alabama. And so you can Google that. There's the name of it there is at the bottom of the screen. So again, it's another good reason to actually download the handout, the PDF version, so you'll have all of these links at your disposal. So in Alabama, they actually studied 101 projects representing 678 miles of segments on 2- and 4-lane rural roads that had 2 to 4 feet of paved shoulders constructed, and in some cases, rumble strips or rumble stripes were scored into the pavement within the shoulder. For 2-lane rural roads, the analysis resulted in crash modification factors of 0.79, 0.82, and 0.72 for the combined effect of paved shoulder and shoulder rumble strips. The combined effect of paved shoulder and shoulder rumble stripes and paved shoulder only, respectively. On 2-lane roads, the benefit cost ratios are 42 to 1, 33 to 1, and 53 to 1 for the combined effect of paved shoulder and shoulder rumble strips, and the combined effect of paved shoulder and shoulder rumble stripes and paved shoulder only, respectively. So these are huge benefit cost ratios. Okay, pavement edge drop off. Let's talk about what we can do for this. You can usually see pavement edge drop offs following resurfacing projects, or it's just a matter of settling, the shoulder settling or erosion or even tire wear. So you can see the picture there on the left. That's very dangerous when you have a pavement edge drop off of that much. That might be 5 or 6 inches there. So when the front right tire of a vehicle goes off the side of the pavement, it can be difficult to get back on there, and then what happens is the driver will overcompensate when you don't immediately get back on the road, so they overturn the steering wheel, and so when the tire is done scrubbing against the edge of that pavement and it actually comes back onto the pavement, then the vehicle overcorrects and shoots left of center line. And that's how a lot of these really bad crashes happen. So we actually have a video here. Let's run a video here. Okay, so that was obviously a test condition there for what happens when you have a pavement edge drop off, but they had lots of room to recover there. So you can only imagine, though, when you're on a 2-lane rural road and you don't have all that room. So you would, go off you cross the center line, either get involved in a head-on crash, or you continue on and go off the left side of the roadway. And then, nothing good happens from there. You're either going to hit a tree or you roll over or something really bad. So we got to do our best to prevent this type of crash. And so we do that with this countermeasure. It's called the safety edge. And so, they have a playing card with the information on the safety edge that you can check out. But what we're doing with the safety edge is we're consolidating the pavement edge into a 30-degree shape during the paving operation to provide stability for vehicles recovering from a roadway departure. And we can implement this as a standard practice for paving and resurfacing projects, especially for 2-lane rural roads. And so this has been around for a while now, so we have some good data for crash reductions on these 2-lane rural roads. So by using a safety edge, we can see crash reductions on 2-lane rural roads from the drop-off type of crash, which is reduced by 35%, run off the road by 21%, head-on roadway departure crash of a lowering of 19% or an 11% drop in fatal and injury crashes. And again, we have a resource printed up by the FHWA called Safety Effects of the Safety Edge. And so you can see there on the bottom right, and you can there's the link to that document with the latest information on that. So here we have some pictures, and you can tell me which is the most recoverable. So these photos show the original Safety Edge project location about 10 years ago after construction. So the road had been constructed using the Safety Edge boot on one side of the road and standard paving practices on the other side. The pictures were taken directly across the roadway from each other. The side with the Safety Edge shows the increased durability and the stability of the Safety Edge, even though the shoulder material has eroded away. So, you know, after a resurfacing project, we always put down some aggregate and bring it up to the edge of pavement. But, you know, this was taken a few years after that, so all that had eroded away. And so as you can see here, we've got a 30-degree angle on the edge of the pavement, which has been studied to show that it's very easy to get back on the pavement with that. And then on this side of the road, there's just a straight drop off, plus the edge of the asphalt has begun to unravel. So there's actually, you get the benefit of a nice compacted edge that does not unravel if you have the Safety Edge. So this was the first time they used it is actually back in the summer of 2003, and the photo was taken in 2011. So it was more than just a few years between the paving and when the picture was taken. Okay, so what good do we get out of this Safety Edge? So let's talk about the crossover type of collisions. Opposite direction fatal crashes predominantly occur on undivided highways in rural areas with posted speeds of 50 miles per hour or greater. And the NCH RP Report 500 Volume 4 that deals with head-on crashes reported that only 4.2% of head-on crashes involved a passing vehicle. So if you're thinking that head-on crashes on two-lane rural roads are mostly the result of people passing another car, then you're wrong. So only 4.2% of those head-on crashes happen because of a passing vehicle. So our statistics here on this slide come from the fatal accident reporting system from 2014 to 2016. So if we're looking at the data for rural roadway departure head-on fatality, so these are fatal crashes, where do they occur? So 87% of these crashes occurred on undivided roads, and 84% of them happened on roadways that had a speed limit of 55 miles per hour or greater. And 32% of these crashes happened in curves. And of the roadway departures, fatal crashes, 28% of them involve head-on crashes. So these are the statistics that we're looking at and trying to do something about, lower the number of these crashes. Okay, let's take a look at this video. This is a head-on crash happened in Arizona. So that video was captured by a speed enforcement camera near Tucson, Arizona, shortly after 6 a.m. And you can watch the, what is that, a bus? Let's go back to that. Watch it one more time. You can watch the bus, how it was moving towards the shoulder before the crash because it could see it coming. Is that a pickup or a bus here? Yeah, it's a bus, school bus. You can see that the bus driver saw the whole thing coming. So this indicates that the small car was angling toward the bus a long time in advance of the crash, and it showed a low angle crossover path. So miraculously, nobody was seriously injured in that crash. So I think what it was is somebody fell asleep at the wheel. So with that said, what is a countermeasure that we can install to prevent this type of head-on crash? Let's look at different countermeasures. So one is to provide a buffer area between opposing directions of traffic. This can reduce head-on crashes. So a centerline buffer area, and of course that's if you're lucky enough to have the width of pavement to install such a countermeasure. But to provide more separation between opposing lanes, a wider center area might be considered. This may involve reducing the lanes or shoulders. And this countermeasure is typically about 2 feet in width, which is needed to establish a good buffer. And for this, a pattern like the top right, as we can see in the top right picture, is best. If 2.5 feet or greater, a pair of double lines or center lines has more target value. A 4-inch normal width line produces a 12-inch wide center line. So you have your 4-inch line and a 4-inch space and another 4-inch line. So that's what you have with the typical double yellow line. The crash reduction factors that you see there on the bottom right are preliminary results for the NCHRP Project 17-66, guidance for selection of appropriate countermeasures for opposite direction crashes. But hopefully they are no longer, that was supposed to be totally completed in 2019. So hopefully you can go to that NCHRP Project 17-66 and see the final numbers in that. Another counter measure is our clear zone. So what is a clear zone? A clear zone is the unobstructed traversable area provided beyond the edge of the through traveled way for the recovery of errant vehicles. So there's a playing card which has the clear zone information on it. The concept of the clear zone, that's our definition. And its importance is only for the understanding of why the countermeasures are effective in reducing rollover crashes, reducing crash potential or crash severity, flattening of the slopes, removal of trees in the clear zone, and adjusting the width of clear zones are countermeasures. Location of applicable countermeasures are typically in the clear zone. So the picture that we see shows a steep slope in this picture here. It's a 2-to-1 slope or greater, and typical section slopes here in that area are 3 or 4-to-1 or steeper. So we're going to go over some countermeasures that all work to provide a reasonable clear zone. So in the left here is a picture from Utah, and the right is the state of Washington. So obviously not much of a clear zone on the right if we have a big tree right off the edge of pavement. So how much clear zone do we need? And so this table was developed, and you can find it in the roadside design guide, which you see on the right. You can download that for free. The AASHTO roadside design guide provides guidance for the width of the clear zone. These values are based on a couple of studies that found that about 80% of vehicles stopped within 30 feet of the traveled way when they left their lane of travel to the right. The values were factored for speed, average daily traffic, and side slope, but are still considered to address about 80% of encroachments. So you've got your design speeds on the far left of the table. You've got 4 different design ADTs in the second column, and talks about the slopes involved, the 4 slopes and then the back slopes. And the end result is how much clear zone should you have in those situations. You know, typically we see the number 30 feet thrown around with ODOT roadways. But you can see, depending on the different variables, they recommend different widths of the clear zone to handle at least 80% of the different encroachments. When we say a traversable slope, what are we talking about? So if we look at 1 to 4 or flatter, that is traversable. So we've got some pictures here on the right. So that is a 10-to-1 slope that you see at the top right. And what does a 1-to-1 look like? That's the bottom right picture. That doesn't look very safe, does it? That's actually pretty scary. I think I get nightmares from that picture. So roadside slopes that are 3-to-1 or flatter are considered traversable. This means that in most cases, an errant vehicle can cross over these slopes without rolling over. Slopes that are 4-to-1 or steeper are also considered recoverable. So you've got 2 terms there. You've got traversable and you've got recoverable. Recoverable means that the driver can actually start recovering control on the slope. Slopes steeper than 3-to-1 are considered critical, and depending on their height, a barrier may be appropriate. So if you're wondering where those pictures are, the top is in Florida, the bottom picture is in Washington State. So, you know, we want to prevent rollover crashes from happening. So that's what happens when our slopes are too steep. So let's take a look at some information on our rural roadway departure rollover fatalities. Again, this is more information from the FoRRRwD, which again is the Fatal Accident Reporting System. This data here is from 2014 to 2016. So we're talking, it's information about rural roadway departure rollover fatal crashes. So 78% of these type of crashes happen in areas where the speed limit is greater than or equal to 55. 44% of them happen in curves. 49% of them occur on collector and local roadways. 76% of them occur on 2-way undivided roadways. 93% of them happen on our 2-lane roadways. And 30% of the fatal roadway departure crashes involve rollover crashes. So that's some good information to know. So as we can see, if we can do our best to prevent these crashes from happening on our 2-lane roadways, that's a big, we could that's a big bang for our buck, isn't it? 93% of them happen on 2-lane roadways, 44% happen in curves. So, you know, we need to do our best, obviously, to focus on in our curve situations. We've talked about curves quite a bit. Let's take a look at a rollover crash. How's that for a wow? That guy was pretty lucky to walk out of that crash, wasn't he? A car doesn't even look like it was designed to be a test vehicle. That's quite astounding to watch, isn't it?
And Ray, we are just past 11:30.
Okay. All right. Well, I guess I've had so much fun, I lost track of time. But you know, when we get back together again on, I guess it's Tuesday morning, we'll pick up here where we left off. But you know, we're just kind of sort of getting into the talking about the slopes of our ditches and you know, what we can do to make them safer, recoverable, or even traversable. We'll start off here where we left off, and just so you know, this picture that I'm showing you here on this slide is actually the location of a crash where Morgan Freeman, the actor, was actually in a crash at this location. So he's obviously still around, so he did, you know, survive the crash, but this is the location where he had a crash. So okay, well, I guess that's it, folks. So if you have any questions, and just because we're kind of over our time, we'll just remember your questions and or comments, and we'll pick up on Tuesday morning here where we left off. How's that sound? So again, thank you for attending, everybody, and I swear we'll be getting caught up with all the certificates, and I've had some questions about certificates, so we just happen to be behind, but we will be catching up through this week. And again, I'll see you all Tuesday morning. Okay, bye-bye.
All right. Thanks, everybody.